Transformers and reactors are key components of electrical power systems. They are used to transfer electrical energy from one circuit to another while maintaining the same frequency. Transformers are used to step up or down the voltage of an alternating current AC power supply, while reactors are used to limit the flow of current in a circuit. Transformers and reactors are critical components in the generation, transmission, and distribution of electrical power. They are used to transfer electrical energy over long distances, and to match the voltage levels of different parts of the power system. Transformers are also used to isolate different parts of the power system, providing protection against faults and reducing the risk of electrical shock. Reactors are used to limit the flow of current in a circuit, reducing the risk of overloading and damage to equipment. Transformers are electrical devices that transfer electrical energy between two or more circuits through electromagnetic induction. A varying current in one coil of the transformer produces a varying magnetic field, which in turn induces a varying electromotive force EMF or voltage in a second coil. Power can be transferred between the two coils through the magnetic field, without a metallic connection between the two circuits. A transformer is a passive electrical device that transfers electrical energy from one electrical circuit to another, or multiple circuits. A varying current in any coil of the transformer produces a varying magnetic flux in the transformer's core, which induces a varying electromotive force across any other coils wound around the same core. Electrical energy can be transferred between separate coils without a metallic conductive connection between the two circuits. Transformers are used to increase or decrease the alternating voltages in electric power applications. Reactors, on the other hand, are used in electrical systems to limit the current. They do this by creating a higher impedance or resistance. The higher the impedance in the circuit, the lower the current will be. Reactors can be used in both high and low voltage applications. A reactor is an element containing a coil that introduces inductance into an electrical circuit. It's essentially an inductor used to limit the current in a circuit. A reactor can be either air core or iron core, and is used in both commercial and industrial applications. Reactors are used in power systems for several reasons, such as limiting short-circuit currents, managing fault currents, and controlling overvoltages. In summary, transformers and reactors are essential components of electrical power systems. They play a vital role in the generation, transmission, and distribution of electrical power, and are used to transfer electrical energy from one circuit to another while maintaining the same frequency. Understanding the principles of transformers and reactors is critical for anyone involved in the design, operation, or maintenance of electrical power systems. Current transformers CTs are used in electrical power systems to step down the current from a high value to a lower value. CTs provide a secondary current that is accurately proportional to the primary current flowing in the circuit. This step-down current can be used for measurement or protection purposes. A current transformer is an instrument transformer, used along with measuring or protective devices, in which the secondary current is proportional to the primary current under normal conditions of operation and differs from it by an angle that is approximately zero. Current transformers supply the protective relays with currents of magnitude proportional to those of power circuit but sufficiently reduced in magnitude. The current transformer isolates the measuring instruments from high-voltage power circuits. Potential transformers PTs, also known as voltage transformers, are a type of instrument transformer that is designed to provide a voltage that is a precise proportional representation of the voltage in a power line. PTs are used in power systems to step down the voltage from a high value to a lower value so that it can be measured with a standard voltmeter. A potential transformer is a conventional transformer having primary and secondary windings. The primary winding of the potential transformer is directly connected to the power circuit whose voltage is to be measured, and it steps down the voltage to a safe limit. Potential transformers perform the job of reducing the voltage in the power system to a value that can be handled by the normal range of instruments and relays. Ground banks, or grounding banks, are used in power systems to create a reference point for the system voltage, to facilitate the flow of fault current, and to reduce the effects of electrical noise in the system. Ground banks, or grounding banks, are used in power systems to provide a path for current to flow from the system to the ground, enhancing safety and preventing damage to equipment. Effective grounding can be achieved with a grounding transformer. If the PV inverter has an internal transformer with the grounded white delta configuration, a grounding reactor can be used instead by accessing the neutral point of the inverter transformer. Grounding transformers are used in power systems to provide a path to ground for any stray currents, and to provide a neutral point for grounding purposes. They are typically used in scenarios where the system neutral may not be available, where the neutral of the system is not of sufficient capacity to carry fault current. These components play crucial roles in power systems, ensuring safe and efficient operation. They allow for accurate measurement and control of electrical parameters and provide protection for both equipment and personnel. Differences between CT and PT and basic principle. CTs are based on the principle of current induction, while PTs are based on voltage induction. Application areas. CTs are primarily used for current measurement and protection, while PTs are mainly used for voltage measurement and protection. Output type. CTs output current, whereas PTs output voltage. Ratio. CT output is related to the ratio of the measured current to the rated current, while PT output is related to the ratio of the measured voltage to the rated voltage. Typical application cases. CTs are commonly used for current monitoring and overload protection, such as measuring the secondary current of transformers. PTs are used for voltage measurement, such as measuring voltage on high voltage lines or providing voltage signals to relays.